Today we are going to read about another topic of glycogen metabolism, that is glycogenesis. As I have already described, the glycogenesis is the formation of the glycogen from a glucose molecule. So to form the glycogen molecule from the glucose, we need ATP, UTP and a glucose molecule. So now let's discuss the step by step how a glycogen molecule is formed. So before starting the glycogenesis, I want you to read the brief introduction of the glycogen. The glycogen is the branched chain structure, and today in this video I'm going to describe about the various steps from how the glycogen is formed from a glucose molecule. Now let's start. So mainly in the glycogen metabolism, that means in the formation of the glycogen for the glycogen synthesis, it mainly occurs in the 4 steps. So first is synthesis of the UDP glucose, another is requirement of primer to initiate the glycogenesis, another is glycogen synthesis by the glycogen synthase, and formation of the branches in the glycogen. So these are the 4 basic steps, preliminary steps that you should know in the glycogen synthesis, and these are the detailed steps of the glycogen synthesis. Now when we have a glucose molecule, with the action of the enzyme glucokinase or hexokinase, with the help of ATP, we obtain a molecule glucose 6-phosphate, and upon the action of the phosphoglucomutase on the glucose 6-phosphate, we get glucose 1-phosphate molecule. And glucose 1-phosphate molecule, in the glucose 1-phosphate molecule, upon action of the UTP glucose pyrophosphorylase, and with the help of the UTP, we get UDP glucose. So the first step, the first thing in the glycogen synthesis, the synthesis of UTP glucose, we obtain the UTP glucose. Now we have the UTP glucose. Again, we have a glucose molecule, and on that glucose molecule, glucokinase or hexokinase acts, and there is the formation of the glucose 6-phosphate, and with the help of phosphoglucomutase, we have a molecule glucose 1-phosphate, and UDP glucose pyrophosphorylase acts on the glucose 1-phosphate. With the help of UTP, we get UDP glucose. UDP glucose stands for uridine diphosphate glucose. And now next step is the requirement of the primer to initiate the glycogenesis. So a small fragment of pre-existing glycogen must act as primer to initiate the glycogen synthesis. But in the recent studies, it is found that even in the absence of the glycogen primer, a specific protein, namely glycogenin, the glycogenin can accept the glucose from UDP glucose. So the hydroxyl group we see here, the hydroxyl group of the amino acid tyrosine of the glycogenin is the site at which the initial glucose unit is attached. The enzyme glycogen initiator synthase transfer the first molecule of glucose to glycogenin, as you can see. So the enzyme glycogen initiator synthase transfer the first molecule of glucose to glycogenin. Then the glucogenin itself takes upon few glucose residue to form a fragment of primer, which serves as an acceptor for the rest of the glucose molecule. As you can see there, we get the first glucogen primer with the help of glycogen initiator synthase. And with the help of the glycogen synthase, we get a full linear unbranched molecule. So we get the linear unbranched molecule. So the glycogen synthesis by the glycogen synthase occurs after the glycogen initiator synthase. The glycogen synthase is responsible for the formation of 1,4 glycosidic linkage between the glucose molecule. So this enzyme transfers the glucose from UTP glucose to the non-reducing end of the glycogen to form alpha 1, 4 linkage between the glucose molecule. So we have a linear unbranched molecule of the glucose. Now what happened? As I've already said that the glycogen is the branched molecule. So there should be the formation of the branches in the glycogen molecule. Now what happened? The glycogen synthase can catalyze the synthesis of linear unbranched molecule with 1, 4 glycosidic linkages. So glycogen, however, is the branch tree like structure, as I have already told, and the formation of the branches is brought by the action of glucosyl alpha 4, 6 transferase. So the formation of the branch is brought upon by these enzymes, glucosyl alpha 4, 6 transferase. So this enzyme transfers a small fragment of 5 to 8 glucose residues from the non-reducing end of the glycogen by breaking the alpha 1, 4 linkage to another glucose residue where it is linked by alpha 1, 6 bond. So this leads to the formation of the new non-reducing end beside the existing one. So glycogen is further elongated and branched respectively by the enzyme glycogen synthase, and further branching is done by the glucosyl alpha 4, 6 transferase, and ultimately there is formation of the glycogen molecule by these various steps. So I have discussed the formation of the glycogen in brief. Again, I am going to tell you the reaction in the glycogenesis. So from glucose 6 phosphate is formed with the help of glucokinase or hexokinase with use of 1 ATP. And from the glucose 6 phosphate, glucose 1 phosphate is formed by the help of the enzyme phosphoglucomutase. And from glucose 1 phosphate, UTP glucose is formed with the help of the enzyme UTP glucose pyrophosphorylase. And we need the glycogen molecule and glycogen initiator synthase enzyme to form the first molecule of the glycogen primer. And when the glycogen primer is formed, the glycogen synthase automatically form the linear branched molecule of the glycogen. But as we already know, the glycogen is the branched molecule, so branching is required. So this is brought by the glucosyl alpha 4, 6 transferase. It breaks the 1, 4 glycosidic bond and forms the 1, 6 bond between the 5 to 7 glucose molecule. And this step occurs repeatedly. So there will be the elongation by the glycogen synthase forming alpha 1, 6 1, 4 bonds, and there will be the branching by the glucosyl alpha 4, 6 transferase. So the linear molecule of the glycogen forms, and later on the branching is done by the glucoside alpha 4, 6 transferase. And you have to know that in the glycogen synthesis, 2 ATP is utilized. 2 ATP is utilized. So 1 ATP is required for the phosphorylation of the glucose, and 1 ATP is required which is necessary for the conversion of UDP to UTP. So these are the two places where the ATP is consumed. So I hope you understood the various steps of formation of the glycogen. And I want to tell the last reaction where there is use of the glycogen synthase enzyme. So this is the rate limiting enzyme, or this is the rate limiting steps that you should know. This is glycogen synthase enzyme. When there is glycogen primer formation and formation of the linear branched molecule, the glycogen synthase acts upon the glycogen primer to form the linear unbranched molecule. So this is the rate limiting enzyme. Glycogen synthesis is the rate limiting enzyme. So this is the overall reaction and the steps of the glycogen synthesis. I hope you understood this lecture. So this concludes our today's video on the glycogenesis. Thank you.